Hello and welcome to Pareto Code, where we focus on the core concepts that give you the biggest results in programming. Have you ever found yourself writing what feels like the same line of code over and over again? Let's look at a simple example. Here, we need to store and print a list of names. We create a string for name 1, another for name 2, and so on. Then, when we want to print them, we have to write a separate system.out. Print ln for each and every variable. For 5 names, this is tedious but manageable, but imagine if we had 100 names, or 1,000. This is called code duplication, and it's a huge problem. It makes our code long, hard to read, and a nightmare to update. In programming, we have a principle called DRY, don't repeat yourself. This code is the opposite of DRY. There has to be a smarter way, and there is. To solve this, we first need a better way to store our list of names, not as separate variables, but as a single organized collection. For that, we use one of the most fundamental data structures in programming, the array. This is the perfect way to visualize an array. It's a single container that holds a sequence of values. Now, how do we access a specific name from this container? We use an index. This is incredibly important. In Java and most other languages, indexing starts from 0. So the first item, Alice, is at index 0. Bob is at index 1. Alex is at index 2. And Eve, the fifth item, is at index 4. If you want to access Alex, you ask the array for the item at index 2. This system is a core concept you'll use every day as a programmer. So we've solved our storage problem. But how do we act on this data without repeating ourselves? If we just printed names at index 0, then names at index 1, we'd be right back where we started. The solution is our second key concept, the for loop. A for loop is a structure designed to repeat a block of code a specific number of times. Let's break this down, because this is the engine that does all the work. The for loop has 3 parts inside its parentheses. Part 1, the initialization. Int I equals 0. This runs once at the very beginning. We declare a counter variable, I, and set its starting value to 0, the same as our array's first index. Part 2, the condition. I is less than names.length. Before each cycle, the computer checks this condition. Names.length is 5, so this loop will continue as long as I is less than 5. Part 3, the increment, I++. This runs at the end of every cycle, adding 1 to I. The loop runs for I equals 0, 1, 2, 3, and 4. When I becomes 5, the condition is false and the loop stops. Now for the magic. Inside the loop, we use names at index I. We're using our dynamic counter variable as the array index. This prints every name in the array, no matter how many there are. So let's look at the transformation. On the left, where we started, long, repetitive, and hard to maintain. On the right, where we are now, clean, efficient, and scalable. If we wanted to add 100 more names, we'd only have to change the array. The for loop would handle it automatically. And to prove it works, let's run the code. The output is exactly the same, but achieved in a vastly superior way. Let's recap. 1. Arrays. Use them to store lists of related data in a single container. 2. For loops. Use them to repeat an action a specific number of times, often using a counter that works perfectly with an array's index. Mastering this combination is a fundamental step in your journey as a programmer. This was a classic Pareto code lesson. These 2 concepts, arrays and for loops, represent that 20% of the knowledge that will solve 80% of your problems with repetitive data. If this video helped you connect the dots, the most efficient way to show your support is to hit that like button. And to make sure you don't miss the next high-impact lesson, be sure to subscribe. And for our question of the day, what's another real-world example of a list of things you could manage with an array? Let me know your best idea in the comments below. Thank you for watching. Happy coding.